Okay, these are the 9/6 notes. The measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the intercepted arcs. I kind of worked through that here of why. Here you can see angle 1. It's an exterior angle of a triangle, so it's equal to the sum of 2 plus 3. Well, angle 2 is also an inscribed angle, so I knew angle 2 was half of arc DB. And angle 3, because it's inscribed, is equal to half of arc AC. What I then did was substituted the arc measurements into this original equation that I had. So that's where this came from, and then I factored the 1/2 out. And again, we went more into this in class in the discussion and discovery of all of this, but I'm just trying to sum up in the video. Over here, we have the measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside the circle is equal to half the difference in the intercepted arcs. And this proof works out in a similar way, but notice that angle 3 is now the exterior angle instead of angle 1. So I have a little bit of a different statement to start. I have that angle 2 and 3 are still inscribed and equal half the measure of their intercepted arcs. I then substituted that in. I solved for angle 1 and then factored out the 1/2. So I have a summary page here. If the vertex of the angle is at the center, then the arc is equal to the angle. We did that back in section 3. If the vertex of the angle is on the circle, then the intercepted arc is equal to twice the angle, and we did that yesterday in the previous section. If the vertex of the angle is in the circle but not the center, then the angle is equal to half the sum of the intercepted arcs. And if the vertex of the angle is outside the circle, then the angle is equal to half the difference of the intercepted arcs. You may want to draw examples here and pictures to kind of show you what each of those represent. We did do that in class. On the next page, I have a set of examples for you to find angle 1 and angle 2. Go slowly, asking yourself, where is the vertex? Okay, what does that mean? Go back to the summary page. What am I looking at to solve? Okay, so I would like you to try these examples on your own and then come back to check your answers. Okay, over here I have the answers. In the first example, in red for angle 1, I extended and found the intercepted arcs. Angle 1, because it's inside but not at the center, it's half the sum. You can kind of see this as a plus sign. So half of 70 plus 50 gives angle 1 a measure of 60. Then in blue, angle 2, the vertex is outside the circle, so it's going to be half the difference of the intercepted arcs. So you can see it come out. I marked the arcs in blue here and here, and then I found half of the difference. In this one, information changed a little bit. I started with the purple, and I said, well, I know 100 is equal to half the sum of the intercepted arcs. At that point, I did not know what BD was, so I called that X in the purple, plus 66. I solved that equation and found that that was equal to 134, and I labeled that here. Then I moved to the blue because it asked me for arc BC. The 40-degree angle intercepts two arcs. It intercepts arc BD, which I now know the measure of, and arc BC. Again, the division of the arcs is at point B, at the point of tangency. So 40 equals 1/2 the difference of 134 minus X, which I did not know at that point. I solved that equation and found that X equals 54. Okay, then we have two more examples. Good gravy. So I would like you to try these. And come back and check the answers. Okay, in this one, this can be tricky, and there's probably more than one way to answer this question where the red was the center. So I had a lot of people use different things. I think perhaps the easiest way is angle D is going to be half, because vertex is outside, half the difference of the intercepted arcs. And in red, the separation of the arcs is at that point of tangency. So the red arc is one of the intercepted arcs, and the green is the other intercepted arc. Together, these make the whole circle. So if I know that AB is 105, I can find the red by just simply doing 360 minus 105. Angle D is going to equal half that difference. So you can see I put the red measure in of 255 in red minus the green, and that gave you a measure of 75 degrees. And the one below that, this vertex is outside the circle, so it's half the difference of the intercepted arcs. So I just set up the equation where arc AB is x, and I solve that equation. Our last problem's a problem that kind of reviews everything for you. Make sure that you read the given and label that on yours before you start working on the problem. So make sure you label that this is 100, arc CE is 30, arc EF is 25. You know that these are tangent, that this is a diameter. Okay, so please push pause, work through this as best you can, and then come back for the answers. Okay, the answers are here. I know, a little crazy, but AF is a diameter. They told us that here. So arc AF, or AGF, is 180 degrees. Well, if this is 100, then I know, too, that has to be 80, because 100 minus 100, 180 minus 100 is 80 degrees. So our angle, or I'm sorry, 2 is standing for the arc, GF, which is 80 degrees. Angle 1 is a central angle, vertex at the center, so it equals that arc. So angle 1 is also 80 degrees. We were given these red arcs right here. And so to get arc AC, I just did 180 minus 55. That's where this 125 came from. Let's go. We did 1 and 2, 3. This is an inscribed angle, angle 3. So it's half the intercepted arc, 30 plus 25, so that's where that came from. Angle 4 was half of the intercepted arcs, half the sum, I'm sorry. So one of the arcs is this 80 arc. The other one is from E to C to A, this arc, whole arc here, because you have to trace the chords out. So you can see my work there for angle 4. Angle 5, half the sum of the intercepted arcs, so again you can see my work here. Angle 7, or I'm sorry, let's go up to angle 6, half the difference of the intercepted arcs, so you can see my work here. Angle 7, you could have done that this was an angle from a chord and a tangent, so it's half the intercepted arc, but I also know that a diameter and a tangent are perpendicular, so I knew angle 7 was 90 degrees. In angle 8, you could have done half the intercepted arc, or you could have used the fact that angle 7, angle 3, and angle 8 make a 180 degree angle and solved it that way. Okay, so that is the conclusion of the 9-6 notes.